Hello students, this is Amuda, Assistant Professor from the Department of Robotics and Automation. Our subject code is MR3491. Our subject name is Sensors and Instrumentation. So today we are going to discuss about the radiation sensor, smart sensor, film sensor. So these types of sensor we will going to discuss. Okay. So from the fourth unit, this is the part 4. Okay, this video is a part 4. So smart sensors. What is meant by smart sensor? Most of the types of sensors are the smart. That is, these sensors are having sensing elements and electronics are integrated on the same chip. That's why we are calling it as a smart sensor. Okay. The integration of electronics and sensors, this is to make an intelligent sensor. So that's why we are calling it as a smart sensor or intelligent sensor. Okay, so this can make some decision, and also this have the multiple benefits. For example, higher signal to noise ratio, that is, it removes the noise easily and also effectively. Fast signal conditioning. Signal conditioning means it converts the digital to analog or analog to digital signals effectively. Next one is auto calibration, and that is it gets the true values automatically. So that is called auto calibration. Next one is self testing, high reliability, small physical size, and detection and prevention of failure. So these are the benefits in a smart sensor. That's why we are using this. It's looking like a chip. Okay, so the definition of a smart sensor is it is used to used as a transducer to gather a particular data from a physical environment to perform a predefined and programmed function on the particular type of gathered data, right? So it transmitted data through network connection. So smart sensor is an integrated device. So the working principle of smart sensor is that is it capturing a data from physical environment and changing their physical properties like a speed, temperature, pressure, mass. So these are converted into electrical signal, right? So this sensor uses the digital motion processor. The smart sensor uses the digital motion processor. This is the one type of microprocessor, so which is used in smart sensor. So it performs the onboard processing for smart sensing. Okay, like filtering noise, otherwise performing different kinds of signal conditioning. It performs not only amplification, filtering, this also performs the signal conditioning. This is the main unit of microprocessor. Here this uses the digital motion processor. Here I gave some small sensors like a proximity sensor, DMP sensor. So here smart sensor block diagram is a sensing unit. Here only we are giving the input. This this input will be give it to signal conditioning. This signal conditioning just extract the noise, and that will be given to or increase the amplitude. Then it will be given to analog to digital conversion. The analog signal will be converted into digital signal. That gives to application algorithms. That means it may be it uses some softwares. Okay, so that software is interfaced with local user, that human beings or anything, right? So now also unidirected with the memory. So it's a storage device. So if use any software means that also the output also generated here only. That output will be given to the transceiver. That's a destination part, that is communication unit. Okay, so this is the block diagram of smart sensor. So I already explained this sensing unit, conditioning unit, analog to digital converter, local user interface, application algorithm, memory, and communication unit. Okay, so these are the theory. I just giving here you just take a notes of in it, then use it. So five types of following this, and lots of sensors are there, but I give some five types of smart sensor: level sensor, temperature sensor, pressure sensor, infrared sensor, proximity sensor. So level sensor, which is used for measuring or sensing the level, some liquid or anything. Next one is a temperature sensor for used to measuring the temperature, and pressure, which is used to pressure sensing. Next one is a infrared sensor, which used to sensing a light. Next one is a proximity sensor, which detects the objects. So these are some types of small sensors. Next one is a film sensor. So film sensor means this sensor is fabricated using a thin film technology. So and also it allows the very small, flexible, cost effective sensors. So the working principle of this film sensor is entirely on that is depends entirely on the specific type of film sensor only. For example, so thin film resistor, so which is used in temperature sensor and also strain gauge. Okay, so the thin film resistor we are using, so which is called as film sensor, right? So these sensor utilize the thin film of a material whose electrical resistance changes with the temperature. Okay, if resistance increased means temperature also increases, resistance decreased means temperature also decreases. So this is what happened in a temperature sensor. So from this we are using that material is thin film resistor, that's why we call it as a film sensors, right? So next, working principle. So working principle in a thin film sensor, first we have to take an example for temperature sensor. For example, resistance temperature detector. In RTD, we are using a thin film of material like platinum. So we are using the platinum. The platinum is a thin film. So that's why we are call it as a film sensor, right? So the platinum is deposited on a substrate. So the temperature changes, the atomic vibration within the platinum film, the atomic vibration within a platinum film increases or decreases, that depending upon the vibration. Okay, so this affecting the electrical conductivity. So electrical conductivity means the resistance will be changed. Okay, so we measure the output as a resistance only or the capacitance, but in the RTD we measure the resistance. Okay, so we are using the platinum, so it's a thin film material, so that's why we are say it as a film sensor. Okay, temperature sensor is a film sensor. So temperature sensor is electrically used sensor. Okay, next one is strain gauge. Strain gauge also using a thin metallic film that is bonded on a surface. So when the surface experiences a stress, strain gauge means which detects the deformation or stress. Okay, so it detects some experience in stress, so the film deforms. So then what will happen? The length will be changed in the area. Okay, so this changes is converted into electrical signal, that is we measure the output as a resistance of the film, right? So by measuring this resistance change, the applied strain can be determined. This is called strain gauge. This is the mechanical sensor. Okay, so this is also a one type of film sensor. Next one is a MEMS. So micro electromechanical system, nano sensors. So here MEMS sensor means it's combined the electrical and also a mechanical components. That's why we call it as a MEMS sensor. So this have we have to take one example for MEMS sensor means accelerometers. So accelerometer which measures the vibration, which widely used in smartphones, cars and other applications to detect the accelerometer, right? So we take the output from the accelerometer by using capacitance. So actually the vibration is that input quantity is that is transferred to the output quantity. That output quantity may be capacitance, not a resistance. In accelerometer the output will be a capacitance. The electrical quantity is measured in the form of capacitance, right? So which is proportional to acceleration. The capacitance is proportional to acceleration. So this is one example for MEMS sensor, that's all. So next one is a laser sensor. So laser sensor means light amplification by stimulated emission of radiation sensor. So laser sensor utilize the laser light for detection. So there is a it measures the distance, okay. So but in two different way. One is a time of flight, another one is a triangulation. Why we are using this means this offer precision, directionality and speed. So first one is a time of flight. This means when laser distance sensor emits a short pulse to the laser light towards the target, that is some light is emit to the target, then this measure the time it takes reflect the light. This measure the time it reflects the light to return, okay. So this is called time to flight. Just emit the light to target and it reflects. We measure the time, reflect time, okay. So that is called time of flight. So it uses some formula. Distance is equal to speed of light into time is divided by 2. This is the formula to calculate the speed or time, okay. Next one is a working principle of triangulation. A laser beam is projected into a target, that is the light beam is projected into target. So creating a spot, it does not return, it does not reflect, it created some spot, okay. So the receiver observes the position of the spot, then he measures the distance. From the spot he measures the distance, right. So the angle which the reflected light reaches the receiver changes, causing the spot to shift in the detector. So by precisely measuring the shift, the distance can be determined using trigonometric principles, right. So this is the laser sensors, so which is used for distance measurement, okay, which is the application of this is distance from the earth to flight, like so we can measure the distance using the laser sensor. So if you have any doubt, please drop the comment below. Thank you for watching my video. So for more lecture videos, visit our website smit.edu.in and kindly follow our Facebook page SMIT Chennai and also our Instagram page SMIT Official Chennai. Thank you.